So guys, today we are going to talk about center of mass. For the previous lesson, we did a lab. We want to find a balance point for a three-coin system. And the balance point we found is called the center of mass. What is the center of mass? Oh, Colin.
I got it, Zavon. The center of mass is the point representing the mean position of the matter in a body or a system.
Yeah, that's a good answer. You're smart, Colin. So, why do we have to study about the center of mass? Why is it so important? So, previous lesson we learned momentum and collision. Previous lesson we learned about rotational emotion. And now let me relate the center of mass to these two units. In the unit of momentum, why is center of mass so important? Because in a closed system without any external force, the center of mass keeps constant, it doesn't change. And for the unit of rotational emotion, the force is acting off the center of mass. And for translational motion, the force is acting on the center of mass.
Mr. Zabong though, do we need to calculate the center of mass?
Of course we need.
But what if I'm really bad at math? Like, how do I do that?
Don't worry, I'm a physics teacher. I will teach you an easy solution using physics knowledge. Let's say we want to find the center of mass of this board. And how do we find this? So, if I draw the shape of the triangle, it has 3 points, A, B, and C. And these two are just the triangle from different perspectives. This one, the point C is on the top. This one, the point B is on the top. So the property we're gonna use here to find the center of mass is force always acts through the center of mass. And now we need the force. The easiest force we can get here is the gravitational force. So for this one, if we hang a mass at point A and just let it go, it will act through the center of mass. But there is only one line. We cannot guarantee the position of the center of mass. And then we put point C on the top and do the same thing. The gravitational force will also act through the center of mass. And for this one, point B on the top, if we do the same thing, the gravitational force will still act through the center of mass. The intersection of the three lines will be the position of the center of mass.
Wait, but Mr. Zabong, how do I calculate this using the calculus part?
You can, just Jerry,
Dude, you're so bad.
I'm a teacher. Talking
You
about.
don't even know how to do the calculus part? Man, we'll roll with these ugly physics diagrams. Let's erase them. To a calculus reason, you need to know how to do it algebraically. Algebraically, you first need to use the equation. This, when you use the example of this triangle right here, is that you're assuming all the masses are concentrated around 3 points. And each point have a mass. If we graph this whole triangle on a coordinate system, the x value of each, so we multiply the x value of each point by the mass of this point, then you add all the points together, divided by the total masses of these 3 points. That's how you get the algebraic. And this gives you the x coordinate. And similarly, this equation gives you the y coordinate. Now you guys have understood the algebraic solution. Now I have to do a calculus solution. To find the calculus center of mass, you separate into the x and y component just as the algebraic solution. For the x component, you use the equation 1 over a times from a to b the integral of x times function of x dx. And for the y component, you use 1 over a times from a to b integral of 1/2 function of x squared dx. And now, this may look really complicated, but in a sense, this is the same thing as the algebraic solution, except that you're using an infinite amount of points. Okay, so let me give you an example. Let's use this function. The heck? Zavon, I need a new pen! Whoa. Function of x equals to, let's see, x over root 1 minus x squared. So, we first do the x component. So the area will be equals to, from x is from 1/2 to 0 over root 1 minus x dx, which equals to have u to the negative 1/2 du, equals to 1 minus x as u. Plug into this equation, and this becomes next. After we can now find the x component. For a y value, which equals to, if we just take the integral part, to 0 to 0.5 of 1 minus x squared over 1 minus x squared 1. After you evaluate everything, it becomes 0.0493 over 1 minus root 3 over 2. And if that is the x and this is the y, then you find it in terms of decimal.
Jerry, good job.
I'm going back to sleep.
Okay. I just used the method you taught us on 3 points of the center of mass. The physics point, the algebraic point, and the calculus point. However, I found that the physics point balanced the best because doing this thing from the real object, and the physics one, we use gravitational force, which is closest to the real life scenario. And for algebraic and calculus thing, we have a lot of measurement, and it might contribute to the source of error. So I still think the physics is the best way to find the center of mass. Okay guys, this is today's class, and thank you very much.
Oh, sorry,
gosh.
we're late.
The class is over.
What? What did we learn?
Center of mass. Now I have to teach you guys all over again.
The center of mass is so easy.
So easy?
Yeah.
You are not a humble student at all.
Well, it's just me.
Then teach me what is center of mass.
Okay, so center of mass is a point representing the mean position of the matter in a body or system. And if you wanted to find center of mass using physics, say this is a ball, and then you have, like, it's on a table, and you wanted to find where gravity was acting through. Gravity would be acting through the center like this and down. And then where the point crosses in that's the center of mass.
Oh, that's exactly the textbook say. You are a genius, Erwin. How about you?
From the calculus perspective, as we all know, the center of mass is the point at which all the masses of an object is centered about and will maintain balance. So here, in order to find the center of mass in a two-dimensional system, we have to use the sum of the masses times the distance and divided by the sum of the masses. And here are our formulas. So by using those two formulas, we have the object position along the x-axis, and we got answer of 0.3125. And similarly, we also find the y-axis. Answer is 0.208.
Oh, you guys are so smart. You don't even need a teacher. The class is over. Let's go.